Okay, I think we'll get going. First off, are there any questions? Okay, so we're getting down to the end of the semester. We're going to talk about some applications. We're going to talk about sustainability. We're going to talk about safety. We've covered a lot of the material and printing process stuff that we're going to cover unless you ask questions like how many different types of peak are there, or how do you make a carbon fiber ABS composite, with some examples. And so if you have like specific 3D printing questions, feel free to shoot those to me by email or put them in the discussion group on Canvas. I'm happy to cover more sort of nitty gritty technical stuff. But for those of you who this will be your only 3D printing course, perhaps, at least at Penn State, I want to cover a few other things to outline the 3D printing ecosystem, to get everyone on the same page as to where 3D printing is going to be important in the marketplace, and what people are doing now to promote the industrialization of 3D printing. And you got a little hint of this last lecture when we talked about economies of scale and the comparison of additive manufacturing versus conventional manufacturing. And we will continue to hit some of those themes in the last part of the semester here. But backing off on the technical part gives you some time to consider your papers and your presentations, gives you some more time to read some papers, to think about exactly what you're going to talk about. I also put up an assignment to help you accelerate your end of semester work. So I didn't know whether to make it due before or after break or sometime. So I just put it after. So please try and do some thinking, as you're digesting turkey or watching football or sitting at home by yourself, like I may be, without visiting family. At least, think about what your paper is going to be, work on an outline. Some of you already have a really good idea in terms of references, and you're all set. I think a few of you still have some work to do in terms of nailing down specifics, and I gave you some feedback on your project ideas. But I'd really like to see after break, like, what you're doing, you have an outline, you're all ready to go. And I promise doing a little bit of work now will help you at the end of the semester. So if you don't understand my comments on your project idea, or you want to talk about it, or you're really stuck, or you don't understand the new assignment I just posted, let me know. I have plenty of time in the next couple weeks to facilitate this in any way that's useful for you. And I saw some really cool ideas. Some of you that are experts in 3D printing, you wanted to learn something new about your specific technique or materials. I saw some others where people were interested in new types of 3D printing or bioprinting. I saw some others about properties that we haven't particularly talked about, like flame resistance and other key things that certain industries care about. And so there's lots of good ideas floating around out there. And if you need input from me, I'd be happy to Zoom or exchange emails or whatever is helpful. But please do a little bit of work this week and over break, and it will pay dividends in December for sure. So any questions? Any questions on the new assignment or previous assignments, or any technical questions here? All right, so we'll continue like this, and we have lecture today, lecture on Thursday, and then remember there's no lectures, even online lectures, during the week of Thanksgiving, and then we'll pick it up for the end of the semester. So now's the time to start planning how we're going to get out of this semester successfully and happily. So last time we were talking a little bit about process modeling and this really interesting paradigm of new designs for 3D printing that are excuse me, in some cases enabled by new software. So this is really interesting piece of integrated software here, where now the CAD software, where you design the 3D printed part and even the materials specifications, come with knowledge of the printer. So this is following up on some of the PolyJet printing that we've seen from the MIT group, where they use the PolyJet to make their 4D printed structures. But now embedded in this piece of design hardware, or what they call the foundry, is knowledge of how PolyJet works. What are the materials? What are the resolutions? What's going on in the manufacturing process? And that's coupled to the design software. And a lot of this is out there, and I think it was it Kyle or Eric that we were talking about how Markforged couples their design software in order to help designers think about the shrinkage that's going to happen when they do their metal-based FDM. So for those of you who aren't familiar with what Markforged is doing, or Desktop Metal, excuse me, is doing in terms of printing, is that some metal FDM or metal extrusion processes have binder in the extrudate. So it's like material extrusion AM, or it is material extrusion AM, but it's a mostly metal filament with some polymer binder in there to get the thermoplastic behavior. But when you sinter that metal, because there's a bunch of plastic in there, the part shrinks. And so they have embedded in their design software and in their print planning software that shrinkage. And I couldn't find online whether it was anisotropic or isotropic, but that's something that people are working on, where now, in order to get the shape resolution that you want, you need to have this knowledge of the process. And then in a lot of cases, then you have software correction for successfully 3D printing what you want. So this is just a simple idea of that. And MIT has a nice video of that, but I think you'll encounter more and more some of this design software with knowledge of the process embedded in the software. And this is starting to happen in some of the big packages like SolidWorks and AutoCAD Inventor, but this is where things are headed. In terms of modeling and simulation of additive manufacturing, this is a big field. And I just wanted to point out that there's whole conferences on this. Then these are some of the topics that folks are interested in. So computational methods for correcting part distortion in design, or simulating the manufacturing process to get residual stress or microstructure, modeling and simulation of biological tissues, topology optimization, which we already talked about, feedback control. So there's a lot going on at Simp3D at Penn State about how do you do rapid data acquisition and then feedback control, either to minimize defects or to understand the structure to begin with. How do you simulate smart materials, sensors, nano devices, really complicated stuff with multi-materials? And how do you integrate process modeling and process design? These are all key concepts that are out there for what does the next generation of additive manufacturing software and design look like. Any questions on this? Okay, this is finishing up lecture 13. We will talk about what we're really going to talk about today, which is lecture 14. So you can go to the box folder and bring up lecture 14, if I can find it. And so, like I said, we're going to continue on the path of talking about industrialization of additive, and that includes markets, sustainability. We'll also talk about safety. We'll talk about energy usage. And so this will give you more of a holistic picture of how additive is being incorporated into a couple of key industries that we should keep our eyes on as scientists and engineers. And also, I should mention that this will be somewhat agnostic to polymers and composites. This may go for metals as well. Ceramics doesn't really exist yet in terms of large-scale printing, but some of these ideas that we're going to talk about and some of these ways to analyze 3D printing markets or opportunities for additive manufacturing will be useful if you're interested in binder jetting or in terms of metal 3D printing or something like that. Now, we won't talk a lot about casting, so there's a lot of interesting sand mold making that's revolutionizing the casting industry or slowly revolutionizing the casting industry. And that's got a different set of economics, but these types of discussions might help you think about how whole industries like the hearing aid industry and the biomedical device industry are changing due to additive. So first off, if you're interested in industrialization of additive, you should probably know who Terry Wohlers is. And the Wohlers report is sort of an industry marketing report, a state of the field on additive manufacturing. And so in 2018, they said that additive was going to top $7 billion, at least in terms of the 3D printing industry. So that's interesting. And you see this 21% growth. So that's a big number. And we'll talk about what 7 billion means in terms of the size of markets and what 21% growth means. But 7 billion, and I'll just take this as a caveat now, compared to the other industries that we're going to talk about, like the aerospace industry or the automotive industry, or even the apparel industry, additive manufacturing is still relatively small compared to other big market segments. So even though 7 billion seems like a big number to us, this is still a relatively small industrial market with high growth. And so that's something to keep in mind, is that additive manufacturing is still a real growth industry, but it's not huge compared to some of the other stuff that we're going to talk about, which means it's got a lot of potential. And so if you look at some of this, and this is 2018, so we're talking about a couple of years ago, and certainly at 21% growth, things change. But they're talking about how many 3D printers are sold each year. And these are not desktop systems. These are not hobbyist systems. These are industrialized, large-scale additive manufacturing systems. So these are the $10 million printers or the $2 million printers. This is the big stuff. And you see here, there aren't that many large-scale AM systems sold per year. And so this is really interesting because it just goes to show you that the market is still relatively immature. There's companies still buying these, and you see the trend is pretty interesting. So 983 of these, let's call these large-scale industrial additive systems. So this is from people like Stratasys and 3D Systems and Vision Tech. Etc. This is probably not from people like Form Labs, definitely not from people like MakerBot, or although MakerBot is part of Stratasys now, or LF Objects. So these are not desktop or hobby printers, as we would say. But it's growing. So these are growing significantly, and that's providing a lot of opportunity for new companies to come in, for new types of machines to be sold. So we have a couple of 3D printing companies in State College, actually. One sells metal 3D printers. And so there's opportunity to come in and supply hardware to people that are interested in industrial 3D printing. And this report also misses places like GE that build their own additive manufacturing systems. And so General Electric has additively manufactured parts in some of their turbines, but they've taken the tack that they tend to manufacture or build their own additive systems to do very specific things that they want to do. But this gives you some idea of what's out there. And so what's interesting in this report is that the companies are really starting to grow, and they're interested in not only growth of the machines, but there's more companies making the machines, plus more materials companies. So just because you have an additively manufacturing machine or an additive manufacturing machine, you need materials for that, you need service, you might need filters for that. And so there's a lot of ancillary industries that sort of go along with the industrialization of additive. And so you see all of these desktop printers. That's a lot of desktop printers that are sold. And so that's cool, but these large scale machines are still relatively scarce. Like for instance, Penn State might get one new large scale additive machine a year. And there's probably 50 other universities that get one or two machines a year. Big companies are buying one or two machines a year. And so that's, well, there's a lot of hype and a lot of interest around AM. It's still relatively small. But when you compare it to lots of desktop printing, there's 500,000 desktop printers sold in 2 years. That's very interesting. And so these are just some ideas of desktop printers right here. And then the idea of AM products and services, that's very interesting. So big companies like Airbus, Adidas, Ford, Toyota, Stryker, etc. These folks in general, with the exception of GE and a couple of others, these folks in general are interested in buying capability or buying processing capability for AM, not necessarily building their own machines. And so let me put HP here too, because we talked about HP. They're actually a big manufacturer of additive manufacturing machines now. And so this is how the market is constructed. There's the product companies, Adidas, Ford, Toyota. We might call those the OEMs or the suppliers of products that people buy. And then there's the whole industry around them that basically make the tools, make the materials. Dow Chemical doesn't sell many products directly to people, but Dow Chemical sells an awful lot of plastics to companies like Ford and Toyota that they can make cars out of. And so this is sort of the supply chain or the ecosystem with how additive is being rolled out. Are there any questions on that? Sort of shifting gears rather than thinking about materials technology and additive manufacturing machines to thinking about markets and how companies have relationships with each other to do what they want to do. Any questions or comments? Okay, well, some of you will work for companies like Adidas that make consumer products. Some of you will work for companies that supply Adidas, say with polymers. That's interesting. And there's also a lot of companies that don't necessarily sell products to consumers, like ExxonMobil makes the gasoline, right? They have their Exxon stations and they distribute that. But there's a lot of companies that sell products to ExxonMobil to do what they need to do. Where do you buy an oil rig? You know, or in ExxonMobil's case, at least, you might rent it from another company. And so, thinking about these different places in the supply chain, you can think about all the different places where additive manufacturing might come in. So you don't necessarily have to additively manufacture shoes. Maybe you additively manufacture the molds that people are going to use in shoes. Although Carbon and Adidas have come up with the Futurecraft 4D, where they're actually making the shoes. And so there's lots of different places where additive can insert itself into industry. And so this is just another market report here. Of course, whenever you hear a market size, it's got error bars on it. And so this idea of high compound annual growth rate on the order of 20% is really interesting and provocative for additive. And you see here the market sizes, 4,000 millions is 4 billion. And so there are various opinions as to how big the additive manufacturing market's going to be, but this would be 16 billion in 2025. Okay, so you can find lots of information out there, and these are some resources for you. Now, what are the key markets, or what are the key impacting factors that are interesting in terms of additive manufacturing? And this spider chart is interesting because it changes a little bit from 2014 to projected 2025. So one of the impacting factors for the marketing of additive manufactured technology is the high cost of 3D printing. So a couple of years ago, everyone was saying, well, 3D printing is too expensive. And of course, if something is valuable and too expensive, and you have a bunch of scientists and engineers working on it, in general, the costs are going to go down. So cost of additive now, of course, if you want to start up additive from scratch, you need to buy an additive machine. You need to get people trained on it. There can be significant startup costs. And some companies are interested in that in terms of their research. And some companies are still thinking about whether or not that's a cost that they want to bear. But year by year, the cost for additive is going down. So that's a good trend that will increase the industrialization of additive manufacturing processes across whatever industry you're interested in. Also, this idea of logistics management, so this is materials, software, supply chain, that's improving. So in the past, it was really hard to ship metal powder. It was hard to get some of these processes certified in terms of the supply chain. It was hard to find raw materials. So if you wanted a different grade of polymer, say that was a carbon fiber or chopped carbon fiber composite, it just didn't exist. So you had to go contract that out to be made. But the supply chain or the logistical management is getting much easier for additive manufacturing, and so that will be important going into the future of 2025. Ability to provide customized products. That's a little bit of a wash. Well, what we could additive in 2014, we're a little bit better at in 2025, but we've always known that additive is really good at this. So if your whole industry is based on the ability to provide customized products like hearing aids or perhaps like apparel goods, additive is where in general you'll be. And so we see that industries where you need very detailed customization like jewelry or like hearing aids, additive has really taken off. And there's no change from now or from a few years ago to a few years in the future of how that will be. Growth of additive and automotive. This is big. We'll see how big the automotive market is. It turns out there's lots of cars that are made, and it's a humongous industry. And so not only are cars an iconic personalization statement, they're a high-profile consumer good, but it's a huge industry that employs a ton of people and has a vast supply chain. And so the adoption of additive manufacturing technology by the automotive industry is going to be very big. And we're going to talk a little bit more about that because all the major automotive companies are figuring out how to do additive. But of course, cost is a real issue. So if you're making 1 million cars a year, you need to be able to control costs. And so the automotive industry is notorious for trying to save on costs at each component of the car. And so that needs to be worked through for additive. Healthcare is big as well, and this goes along with customization. And on-demand parts. And so you might think of healthcare as more implants and prosthetics and things like that, but this also includes dental. So dental is a subsection of healthcare, and so there's lots of movement in the dental industry right now with additive. This also includes ophthalmology and optometry, so 3D printed glasses and customization of 3D printed lenses. This is really moving even more so than automotive, because that we know additive is going to be really important in healthcare, really based on the success of what's happened with hearing aids. One of the things that we've had difficulty with in industrialization of additive in the past is lack of skilled labor, and that will actually decrease as a barrier. With more trained engineers, machinists, technicians, designers, etc. So adoption of additive was really held up by education, by training. You know, people just didn't know how to leverage additive in order to do the things they wanted to do. But that barrier is being lowered. It's being lowered at places like Penn State. You're all, or a significant number of you are in our additive manufacturing and design program. That's all about education for additive. And even if you're taking this course as an elective, if it's the only additive course you'll ever take, you know, this opportunity wasn't available in previous years. I mean, this course didn't exist 4 years ago. And so the way that we're educating scientists and engineers and machinists and technicians is just totally different than what we were doing before. And so that's lowering the barrier to adopting additive manufacturing. So this is not necessarily all the major all the major factors in additive, but this gives us a way to think about the different factors that are impacting industrialization of additive and what might change over time. Questions? Any questions or comments on that? All right. So in this, just depending on your interest in the world and where you might want to get a job or settle down, there's a lot of 3D printing going on all over the place. And that you see the growth rate in Latin America and Africa is high for additive manufacturing. So even though, let's say, the industrialization base in Africa is not as high as it is in Asia, there's huge growth potential, especially in under-resourced areas. So big growth in AM for under-resourced areas. So there's not lots of automotive factories in Africa, or there's not a big industrial base for manufacturing products, but that's an opportunity for additive, because the way that you build an additive manufacturing factory is different than how you might build a traditional factory. And so there might be a real opportunity to do innovative manufacturing in places that don't have a big manufacturing base right now. And again, this is part of the opportunity. And so we can compare additive to injection molding. And so from this report, this research report right here, the global injection molded plastics market is valued at $280 billion in 2016. And if you remember, in 2018, in the Wohlers report, the additive manufacturing or 3D printing market was about $7 billion. And so these are quite different sized markets. And of course, injection molding of plastics really plays in packaging, automotive, electronics, home appliances, et cetera, et cetera, et cetera. So there's lots of products and industries that use injection molding and so where can AM show advantages? So maybe it's a very specific piece of automotive, or maybe it's only in medical devices. And so there will be bigger gains for additive in the medical device industry compared to something like packaging, where packaging is very commodity product, commodity polymers, and so it's going to be difficult to get movement there. So this analysis of market size and opportunity is interesting, because if you say, well, I'm going to additively manufacture disposable bottles, but they're going to be really expensive, you know, that's a hard value proposition to make, versus I'm going to additively manufacture custom medical devices because it's really needed. You know, that's where the barrier, or that might be a lower barrier to entry than something that's more commodity. And so if you think about additive manufacturing now, we think about jewelry, or we think about biomedical devices or high-end shoes or dentures. You know, these are all, or hearing aids, these are all expensive products. And so there's a margin to innovate because we can bear the cost of a new process. And we can try some things in these industries that you can't necessarily try in commodity industries. So anyway, the message is that the manufacturing market is gigantic. And right now, the AM market is relatively small. And so that provides a lot of opportunity, but you need to think about where the opportunity lies and think about what's the easiest barrier to entry compared to the alternatives. Any questions or comments? All right, let's keep going. So, this is just an interesting trend in terms of the injection molded plastics market. So what is the raw material? Of course, polypropylene and HDPE, polyethylene, occupy a lot of that. But you see ABS right here, there's a lot of injection molding of ABS, and we know that there's a lot of good material extrusion processes for ABS, so that's an opportunity. We haven't talked too much about polystyrene, but that might provide an opportunity for more additive manufacturing of styrene-based products. And then there's some other things as well. But if you're really interested in large-scale markets for polymers, of course, high-density polyethylene and polypropylene are two big opportunities. And these two polymers are not additively manufactured a lot because the injection molding market is so, or the cost to do injection molding of these polymers are so low, and a lot of commodity components are made out of these polymers. So again, where's the opportunity in terms of mass, and then where's the opportunity in terms of value add for additive manufacturing? So if the injection molding market was big, the automotive market is a lot bigger, 10 times bigger. So the revenue from vehicle sales is on the order of $2.75 trillion. That's really big. Projected to go to 4 trillion. And I can't remember. I can't remember what year this is for, but this is for this probably 2018 when I made this slide. It's from this web link right here, so you can check it out. But you notice these really interesting categories of shared mobility. And so that's alternative public transportation. You see data-enabled services in cars. That's very interesting as well. That's a smaller segment that we probably don't care too much about additive. And then also aftermarket, which means car repair and car customization. And so these are humongous markets. And so automotive, that's why automotive here is defined as a big driver for additive headed into 2025. And so if additive can go from something like $7 billion and take a percentage of something that's like $3 or $4 trillion, there's a lot of growth right there. And so, of course, the automotive market is bigger than the injection molding market. So we're sort of stepping up in terms of orders of magnitude, but this is where the opportunities are. And if you think about a car, there's thousands of parts in a car, and hundreds of those parts are plastic or composite. So we saw an example when we were looking at composite materials of composite frames for BMW i3s and i8s, or other places where composites can be used in automobiles. Even under the hood, there's a lot of plastic ducting, there's a lot of brackets, there's a lot of small plastic pieces right now that are mostly injection molding, but there's been some announcements from Ford and Carbon about the increased use of additive in automotive. And we'll talk about some of these key areas in automotive when we get to talking a little bit more about the automotive market. Aerospace, the whole industry is worth on the order of $800 billion, so almost $1 trillion. And it's interesting that aerospace is a smaller size market than automotive. I guess that makes sense when we talk about the number of cars out there versus the number of airplanes. But this was a little bit smaller than I would have thought it had been. But still, aerospace is an almost $1 trillion industry. And additive has made a lot of gains in aerospace for metal additive manufacturing, for custom components, and now we're getting into additive manufacturing of interior components and high-end plastics for customization not only of commercial aircraft, but of private aircraft as well, which is a booming industry lately. So I think that over the course of the next lecture or two, when we talk about these different markets, you'll hear a lot about aerospace, automotive, and biomedical. I mean, those are the big places where additive can really have an impact because of the advantages of additive manufacturing in terms of customization, in terms of supply chain, in terms of advanced materials. Those things are really important in those industries. And so you'll see this sort of over and over what the key opportunities are. And again, these reports, a lot of them are consulting reports, but they're open, so you can check out these links. These are worth reading if this is something you're interested in to complement your technical knowledge of AM, of polymers and composites. And then finally, retail. So consumer goods, this is $1.5 billion a year, and you see the growth rate here is about middle single digit percents. But apparel apparel may be an important area for additive manufacturing, and so right now we have AM of shoes and jewelry. I don't know if anyone else out there, if there's AM or additively manufactured apparel that you can go buy. I mean, there's been some demonstrations for fashion shows, and of course we saw the video on the 3D printed dress, but I don't know if there's other mass market consumer goods out there other than jewelry and shoes. Does anyone know? You can unmute yourself and pipe in. Trying to think. That might be it. There maybe there's opportunity in dishware, appliances, although those are more industrial goods.
I have one that's more of an industrial good.
Go for it.
I believe it was one of the car companies. It might have been Ford or BMW or something. They were talking about getting into 3D printing, and I heard about this a few years ago at my previous job. And as soon as it's one of those things, as soon as you hear it, it's like, why would they, like, what's their end goal? And they're looking into doing miscellaneous, customizable, like little tchotchkes, like gear shifts or little pieces here and there inside the car that would catch people's attention and basically be conversation starters.
Yeah, so Mini, so Mini has a program on that. So you can buy, and there's a video somewhere. I'll see if I can dig it up. But that's an excellent idea that, these companies, so you buy a Ford Mustang, it's like a lot of other people's Ford Mustangs, right? Or you buy a Mini, it looks like a lot of other Minis, but customization might be in terms of you have a tchotchke, or you have a nameplate in the car, or if you have a new car and you open the door, sometimes they have these entry lights that shine like a little Mustang down on parking lot or something like that. It turns out that Mini has a customization program where you can get those things customized for you, and some of them are made on carbon printers. So I'll see if I can dig that up. I'll put it in the discussion group. But yeah, I think, you know, if you buy a Mini, there's probably an opportunity to sell a $300 customization kit as like an option for your car. So rather than getting, you know, the heated steering wheel, you could get the thing that says Hickner's car or something on the dashboard. And so because cars are a consumer good, people are interested in that level of customization. And the same thing is certainly true for cell phone cases, or certainly true for shoes, you know, things that are, let's say, high profile consumer goods. There's always a chance to upsell that customization and personalization, and additive is great for that.
Very cool.
Good mention. Yeah, good mention.
Thank you.
All right. So moving on, medical devices. You see the medical device market is going to be on the order of $400 billion sooner or later, and they have a compound annual growth rate of on the order of 4 or 5%. And so medical devices are special because, of course, medical devices benefit from customization. And they're also expensive. And so there's an opportunity to sell new technology into medical device manufacturing where that might be a difficult task for automotive. So for automotive, you might have to make it an option, right? An upgrade kit or an option on the car that the consumer has to pay extra for. But in the medical device market, they don't say, well, you know, you could have this sort of standard hip implant that's just going to be so-so. It's not really sized for you. And we'll give that to you at a lower cost than this customized 3D printed hip implant that's going to be a perfect fit. You know, people demand the perfect fit, especially when it's a biomedical device. And so there's an opportunity to really pay for that customization and for there to be an additive benefit in the performance of the device. And so we were talking before about when do you additive and when do you just mass produce? And a really good way to think about when do you additive is when you need something that's customized that you can't get any other way. And what products should be customized. So let's say toothbrushes, you know, lots of people can get the same performance out of the same toothbrush. You know, it's not something that people will pay for. But hip implants or cranial implants that are sized exactly for the industry or for the injury, or a consumer good like tennis shoes that people covet, there's a big opportunity there for customization and for new functions where you couldn't get those before. So medical devices, along with automotive and aerospace, there's a lot of potential there. And we're already seeing that in terms of hearing aids and dental and some orthopedic implants as well. So there's a lot, like I said, a lot of information out there. And this slide is from 2018, and here's the report right here. But they're really talking about where additive is currently used. Of course, this changes every year. So I'll have to update my slides next year when I teach this course. The future applications are happening now, and market forecast. So what types of technology, excuse me, what types of technology are gonna help us realize this future of additive manufacturing? Is it gonna be material extrusion AM, or is polyjet really gonna come to the fore? Or we saw with carbon a couple of years ago, they made big noise in stereolithography. Will there be new innovations within the types of AM processes that are known right now? Or are we going to have completely new additive manufacturing processes that we probably haven't thought about yet? So that's a very interesting question if you're interested in that processing technology part of it. What metrics are going to be important? Build speed, build volume, precision. So we don't talk too much about those sort of machine parameters or engineering goals in this class. We've been focused much more on the materials. But if you're going to build a 3D printing factory, you probably care a lot about build speed, build volume, precision, and also price. And so those things will have different importance depending on what part of the additive manufacturing industry you're in. What are the trade-offs? Strengths and weaknesses, especially compared to traditional manufacturing. And so that's a really interesting question because a lot of industries already know how to make components, right? We have an automotive industry or we have an aerospace industry. You know, people at Frigidaire know how to make a dishwasher and sell it right now. They don't need additive manufacturing, or at least they don't know some of the trade-offs or strengths and weaknesses of traditional manufacturing compared to additive. And so again, this is going back to what are the characteristics of the process and where can you gain a competitive advantage with AM? Because those are the places that AM will be adopted first. So this is something important to think about. And we haven't talked too much about the weaknesses of additive processes. But if we're doing material extrusion AM, of course, you probably have to post-finish it because you don't have a lot of consumer goods with the road extrusion pattern in them. Or if you have, if you're going to do SLA, you know, how are you going to post-finish those? What post-processes are needed? How much curing is needed? What's the resulting strength of the parts? All those things matter as strengths and weaknesses in AM. This is a really important one. And hopefully in this class, you've got a sense for what types of AM processes are compatible with the different material types. And so we saw in material extrusion AM that basically you could just use whatever thermoplastic or thermally processed polymer that you were interested in, like ABS or like polycarbonate or polypropylene if you want. But when you go to SLA and you have different advantages in terms of resolution for stereolithography, you don't really get to use ABS in stereolithography. You only get something that's ABS-like or polypropylene-like, where now the raw material has to be formulated to give you the properties of commonly used thermoplastics. And so that's really interesting, or same with polyjet versus material extrusion AM, or SLS. You know, when do you do material extrusion AM for thermal processing of polymers versus when you might do SLS, which is also a thermal process, but from a powder base now rather than a pellet, extruded pellet or extruded filament base. And so all of these things you need to think about, and it's this idea of the coupled nature of process plus material that's really unique to AM. What currently exists? What printers are out there? What can you access quickly? What's going to take a lot of research and development? What's the price range for all this new technology? What's the market share currently? Where is additive making inroads now? What are the key drivers and restraints of market growth? So what's holding additive back, like we talked about in this previous slide? Lack of skilled labor, was a big thing holding additive back in the past, and that's getting better and better. And so that's something to think about, is what's holding additive back from being adopted. And then if printer technology really starts to change, or if different printer types in terms of machines get out there from, let's say, a couple of years ago to 7 or 8 years in the future, how will that impact the rollout of additively manufactured parts? So these are just some questions that people are interested in asking about the additive manufactured market, and we can start to put the information that we've learned in this class in the context of these market-based questions. One of the things that I've been looking at recently is this really cool special issue, and here's the link right here. Thinking about how additive manufacturing impacts sustainable additive manufacturing, or the environmental implications of additive. Because we know some big industries have a lot of waste. And so, there's a lot of waste in manufacturing. If you're going to build factories, they have a big environmental footprint. So not only do the products that are produced, like, you have to think about how you might recycle a car, or at least get the valuable stuff out of the car, or, what are we going to do about electronic waste and things like that. We should think about how additive is really going to impact sustainable manufacturing in the future, because this will likely become more and more important as people demand that the processes that we use are better and better for the environment. And we're seeing a big shift in this now in terms of consumer goods like electric vehicles and solar panels and other things like that. But this will continue, especially as we think about putting factories in places where factories don't exist right now. So if you're going to do sustainable manufacturing in a new place, or if you're going to do manufacturing in a new place, if it's sustainable manufacturing and doesn't have a big environmental footprint, that might help adoption, because no longer will you have people protesting, why are you putting a dirty factory here? It will be like, oh, this is great. This is a nice, clean 3D printing factory. Please put it here because we want to live close to our jobs. And so this is interesting to think about in terms of how additive might change people's perception of manufacturing. And so what's interesting right in the forward to this set of issues is that they say it's too early to label 3D printing as the pathway to sustainable manufacturing. So is AM sustainable or not? And the question is, or the answer is, it depends. Just like all good science and engineering problems, it really just depends on what the boundary conditions are. It depends what the alternative processes are. It depends on exactly the situation. And with AM, we need to know a lot more about what the material footprints are, energy consumption, emissions, and the linkages between all these different stages of production. So we'll talk about some of the different aspects of this, but the basic message is that additive manufacturing is a complex process. There's lots of things going on, especially when you think about the interdependencies, especially when you think about the material supply chain. All of those things need to be taken into account for a holistic view of sustainability. And so this series of articles that we'll talk about in the last few minutes here starts to get at a lot of these things, and there isn't a lot of conclusions, although there's a real nice paper on energy consumption that we'll talk about. But this is how people are thinking about additive today. I'll pause here. Any questions, any comments so far? Any things people want to bring up? So in your, let's see, I have something in the chat from Paula here. Oh, well, that's a good question. I actually don't know what the impact of COVID is on AM. I do know that AM has been used in a lot of biomedical devices and things where shortages have happened, like swabs, masks, things like that. If someone wants to do their project on additive manufacturing during COVID, that would be really interesting. So there's a free topic for you right there. But there's something called the NIH COVID response print exchange. I won't bring it up right now, but let me take that as an action item. We'll talk about it next lecture if I can find a couple slides to share with you. But because additive manufacturing is a rapid manufacturing technique, there's a possibility that you can shift the supply chain or shift the manufacturing very quickly from certain goods. Say you were AMing, Carbon was doing AM of dentures at one of their suppliers, and they switched right over and did AM of test swabs when they were doing the nasal swab for COVID testing, because the machines that made swabs for this swab testing were not available, or they were in China and you couldn't get products across the ocean when the pandemic was really going crazy this spring. And so that's an interesting asset, or that's an interesting aspect of additive, that the supply chain can be shifted very quickly, because in order to shift what you're manufacturing, as long as you have the materials, all you need to do is change the design. And so I know even in town here, lots of people were 3D printing masks. Lots of people were 3D printing face shields. We saw those news articles. And with injection molding, that's just impossible to get that to happen in very short time scale. And so, I think that in a time of emergency, additive can be really, really helpful. I don't know that there's going to be long-term changes in industries, in the additive industry because of COVID, but we'll see. But I think additive has really proven its worth to do rapid manufacturing, especially when we had so much that was unknown about the pandemic. So that's cool. I don't know that they're additively manufacturing vessels to dispense vaccines or anything like that, but emergency manufacturing is a really interesting aspect of additive. And we won't talk too much about this, but the military is very interested in additive so they can make parts in resource stressed environments. And so if you have a military base out in the desert somewhere, you basically have to truck everything into it because all that stuff is manufactured off-site. But with additive manufacturing, you could make parts for broken down Hummers, or you could make new plastic parts that you might need in your clinic. Or just think, if you break a spoon or if you break a cooking utensil out at some base in the middle of nowhere, how are you going to fix that? I mean, someone from the main supply place that could be hundreds or thousands of miles away has to put a spoon in a truck, and that truck has to deliver you the spoon, rather than just saying, oh, can you 3D print me a new spoon that I can use tomorrow? And so I think in places that it's really, really hard to do traditional manufacturing, additive manufacturing has a big role to play. So good question, Paula. I will try and follow that up. Let me make a note of it right now. So AM for COVID, we'll talk about that either next week or maybe after break.
Yeah, I mean, like, I guess where my question was going is that I know there is like a lot of benefit in healthcare, like with AM, because it's just been growing a lot. But at the same time, like, there's so many companies that maybe are not in healthcare that are not like ready to just, I don't want to say like waste money, but like make really big investments right now on like newer technologies, on like, or newer like types of, I don't know, like machines and stuff, just because COVID like impacts them economically. So I can see like the benefit of AM like right now in some industries, like I said, like the healthcare, but at the same time, I don't know if it's just going to be delayed in some other industries because of the great like amount of expenses bringing this technology to a traditional like manufacturing place implies. Like, does that make sense?
Yeah. So you're talking about sort of more large scale economic headwinds. And so that remains to be seen. I mean, it all depends on how the economy does in the next year. It all depends on, certainly companies have pulled back from some investments because, you know, the markets have gone crazy. People are buying different things now. So if you're selling home exercise equipment, you're doing great. But if you're selling cruise ships, that's a real problem, right? Because not lots of people are going on cruises. And so I think that there will be a slowdown in some industries, but not necessarily in others. And it all depends. I mean, I think it's hard to predict right now how COVID will impact the economy in the next couple of years. It will be slower, but we really haven't seen companies pull back from AM because AM is an investment in the future. It could be more sustainable. It could give the companies flexibility. I mean, what we've talked about on some of our COVID calls is that we need more domestic manufacturing for injection molding. We've run out of some small plastic parts. And so there's been a lot of talk about, well, how do you rebuild uh, manufacturing in the United States? It might actually be through additive. And so I think everything has experienced a slowdown lately, but we haven't seen a particularly bad slowdown in additive. Oh yeah. And Anna just reminded everyone. Thanks for sending that chat to everyone. That they've also been putting printers on Navy ships, because if you need a part and you're in the middle of the ocean, just like being in the middle of the desert, you need to make that part right now. And so a lot of the coolest stuff in AM for rapid manufacturing is happening in the military because they make special stuff. And also, when they break something, they could be hundreds of miles away from a warehouse, and it's really hard to even ship parts from a warehouse to some of the places that the military goes, like the middle of the ocean or like a desert on a different continent where you just can't fly in there. And so there's some really cool stuff happening in defense applications or frontline 3D printing or at these military bases. And so there's a lot of opportunity there for people that are interested in those types of industries.
I've heard an application that is exactly what you were just saying, where this was, I guess, 4 or 5 years ago, so it's probably in full practice by now, but they were putting 3D printers on oil rigs off the coast of Perth, Australia. And Perth is on the west coast of Australia, and everything else in Australia's economy is on the east coast. Take days to get parts there, so they were printing, and you'd have, I don't know, 9, 10 of these oil rigs, and one of them would have a 3D printer on it.
Yeah,
and then you'd print the parts off and helicopter it over to the rig that needs it.
That's an awesome application. I think if we can, let's see if we can find a couple things and a couple links and put them up in the discussion group. But these, of course, if you're going to 3D print electric vehicles, that's awesome. And we can think about Ford really picking this up as a large scale manufacturing technique, or dentures or what have you. But there's an awful lot of niche applications as well that we don't think about for additive manufacturing. And so there's just a lot of cool stuff that can be done. Okay, great discussion. Any other questions or comments? Okay, so this series of articles is really interesting because there's some hidden facets or there's some overlooked aspects of additive technology that will eventually play a role in its industrialization. And so this special issue, and this is lists a bunch of different articles, so you can check this out. And all of you can look at this on the VPN. So make sure you're logged into the library or Penn State VPN before you go to the link. You can see everything from home. So, what does the life cycle assessment look like? What does energy consumption look like for these additively manufactured components? What does the safety look like? So if you go work for a company, of course, safety is number one. Lots of companies will tell you that immediately. And also systematic exposure to emissions and hazards is also an OSHA issue. And companies have gotten in real trouble for this in the past. Things like asbestos, things like dioxane. And so making sure that the emissions are within the OSHA limits is really important. And OSHA has things to say about building an additive manufacturing factory. What does the whole sustainability picture look like? Or what are the benefits that we can derive from sustainable additive manufacturing? And this big one, supply chain. So if you've heard about things like just in time manufacturing, that's an old concept now, but the idea of being able to make parts right when you need them rather than putting them in a warehouse. Other issues of how do you get materials and components for AM. And so if we're going to have large scale AM, we need large scale material producers to be able to supply materials easily for that industry. So right now, if you wanted to go out and buy thermoplastic polyurethane powder for SLS, it's hard to find, it's hard to source, it's expensive. Or if you needed a new type of material for AM, sometimes it's not available. And so what are those supply chain issues, both for the consumer and for the 3D printer, that are going to be important as this industry develops? And so in this article right here, that's part of that collection, there's a lot of really interesting issues that you may have run across in terms of AM, in terms of on-demand parts, on-demand changes of parts, shape, weight, all these things that can be changed on the fly with AM. And so we're going to pick it up next time here because we're going to talk about some of these detailed characteristics of AM processes. And so if you're interested in this, we can keep discussing these aspects of AM. Like I said, if you want to revisit some issues about ABS or about material extrusion AM, make sure you mention that to me. If we didn't cover a specific AM technology or material in enough depth, I'm willing to go back and revisit that stuff to make sure you learn what you want to learn. And also, I'll remind you, take a look at the homework. I'm sorry that it's will be hanging out there over break, but I think everyone will have a couple extra hours of break this time. And so this will help you on your report towards the end of the semester. And so if you can get your assignments in good shape, I think we'll be off to the races to the end of the semester. Any questions? Oh, I see something on the chat. Great. Here, I'm going to get a record of this chat. And so Edward asks, do you think additive manufacturing is more suitable for smaller scale things rather than large scale? So right now, yes, because the printer footprints are smaller. And so we'll pick up here next time And we'll talk about the difference in part size because there are trade-offs. So Eddie, if you remind us of that next time, we'll talk about that part size. Of course, if you're going to build something the size of a house, you need a big printer, but there could be advantages depending on exactly what the application is. So I'll try and remember that for Thursday. Otherwise, I will chat with you all then. Thank you very much.
Thank you.
Thank you.